This is the first problem related to finding the area bounded by a curve. Please take some time to read and understand the problem. When we are solving these types of problems, it would be helpful if we sketch the graph of the curve as much as we can. This will help us in identifying the area or areas bounded by the curve. Remember that when we are sketching a parabola, we must first transform the equation of the parabola to its standard form. Since x is the one which has a quadratic term in the equation, then we shall transform the given equation in this standard form. This is the equation of the parabola after it has been transformed to its standard form. We can see from this equation that the vertex of the parabola is at point -1, 9. And since the quadratic term at the right side of the equation has a negative sign, then this means that the parabola opens downward. This is the sketch of the parabola. Based on what is being required from the problem, this is the area that we must find. However, the problem does not give us the distances of the left and right boundaries of the area. But as you can see in the figure, the left boundary, which is A, and the right boundary, which is B, are just the roots of the quadratic function. So we now solve for the roots of the function. For us to solve for the roots of the function, we shall set y to be equal to 0 and solve for the values of x, which makes the left side of the equation 0. After solving for all the possible values of x, we can see that x equals -4 corresponds to A, the left boundary, while x equals 2 corresponds to B, the right boundary. Now that we have solved for the values of A and B, then we can now solve for the area bounded by the curve above the y-axis or above the x-axis. This is the definite integral corresponding to the area that we need to solve. Solving for the value of this integral will give us 36 square units as the value of the area under the parabola above the x-axis.